A nuclear submarine in space? What would happen if it became reality? Have you ever wondered what would happen if a nuclear submarine were launched into space? Would it survive? How long would it last in orbit? If you're curious to find out, keep watching because the answer is more surprising and terrifying than you imagine. And before you leave, don't forget to subscribe to the channel so you don't miss any incredible content like this. Now, let's dive, or rather fly, into this fascinating question. The submarine in space, an absurd idea or possible? At first glance, it might seem that a nuclear submarine would have a chance in space. After all, these underwater giants are designed to withstand absurd pressures at the bottom of the ocean. So why wouldn't they withstand the vacuum of space? The truth is, the problem isn't the submarine structure, but rather how it would function, or rather, stop functioning outside the water. The hulls of these underwater behemoths are built to withstand pressures of 50 to 80 atmospheres, meaning that holding a single atmosphere of pressurized air inside them would be no challenge. Furthermore, their seals are so efficient that even if they weren't perfect at retaining gases, leakage would be slow. But what about breathable air? This is where things get complicated. Oxygen, the first big problem. Nuclear submarines have advanced life support systems, including CO2 scrubbers that can operate indefinitely, as long as there's power. But oxygen? That's a finite resource in space. In the ocean, these vehicles extract oxygen from seawater using electrolysis, but in the vacuum of space, there's no H2O to decompose. They carry emergency oxygen reserves, but that would only last a few days. After that, well, the crew would be in serious trouble. But wait, that's nothing compared to the real nightmare that would come next: superheating. Is space cold or hot? The surprising truth? Have you ever heard that space is extremely cold? Technically, yes, but it's also incredibly hot. It depends on how you look at it. Strictly speaking, the temperature in near-Earth space is measured by the kinetic energy of particles, which can reach thousands of degrees. But these particles are so rare and tiny that they don't transfer significant heat, just like sparks from a grinder, which are thousands of degrees but don't burn your skin because they're too small. The real problem is that in space, there's no air or water to dissipate heat. All the heat energy is trapped, and the only way to release it is through radiation, a very slow process. This means that any object in space, especially one that produces heat internally, will cook quickly. The nuclear reactor, a thermal time bomb. Now, imagine a nuclear submarine with a 200-megawatt reactor floating in space. About half of that energy is lost as heat, which is normally dissipated by seawater. But in a vacuum, that heat has nowhere to go. It's estimated that without cooling, the reactor would heat the entire submarine by 0.5 degrees Celsius per minute. Within an hour, the temperature would be high enough to kill the crew. And in a few hours, the reactor would melt down, leaving the submarine a ball of molten metal floating in the cosmos. How to deorbit? The unlikely solution. Suppose, by some miracle, the submarine were still intact and the crew wanted to return to Earth. How would they do that without propulsion? Here comes the craziest part: using the submarine's missiles as rockets. Nuclear submarines carry ballistic missiles. If they were positioned backward in the launch tubes, each could change the submarine's velocity by about 4 meters per second. An Ohio-class submarine, with its 24 Trident missiles, could generate enough thrust for deorbiting, about 100 meters per second of velocity change. But this wouldn't be a soft landing. Reentry, a catastrophic crash. Without heat shields or stable aerodynamics, the submarine would tumble and break apart in the atmosphere. The wreckage would burn up like meteors, and any surviving pieces would hit the ground at hundreds of kilometers per hour. If, by some absurdity, someone were strapped into a booster seat inside an intact compartment, there might be an infinitesimal chance of surviving the brutal deceleration. But even then, it would be necessary to parachute out before the final impact. Oh, and one last warning. Disable the missile detonators before attempting this jumping, unless you want to add a nuclear explosion to your already chaotic descent. Conclusion: a terrible but fascinating idea. So, how long would a nuclear submarine last in space? Not long. Between the lack of oxygen, the deadly overheating, and the practical impossibility of returning,
It would be a suicide mission. But what an incredible idea for a science fiction film, right? So, what do you think? Could you imagine other Earth-based machines being adapted for space? Leave a comment below and share your crazy theories. And if you like this video, don't forget to subscribe and hit the bell for more amazing content like this. Until the next scientific adventure.